So previously we run this code, ArcGIS buffer analysis facilities shapefile, and we put the results facilities buffer shapefile 500 meters. So the buffer tool is run and the resulting shapefile is added to the data frame. By default, the buffer tool creates a new feature around each input feature, and the resulting buffers are allowed to overlap. And then if we want these overlapping features to dissolve, we need to set the dissolve parameter. The syntax of the buffer tool is here. We have a buffer analysis input feature, in feature, and then out feature, buffer distance or field, and line side, line and type, dissolve option, dissolve field. So now we can find the syntax by pressing F1. So if we press F1, and then there are some information here. And if we want to know the buffer, and then the dissolve option is an option parameter for the buffer tool. If we're not familiar, we still can search, look at the buffer tool. And the optional method and dissolve fields. So right here, dissolve is right here. So now the dissolve option is an option parameter for the buffer tool. Because it is preceded by two optional parameters, we're going to skip them using two empty streams. So that's how we have ArcGIS buffer and analysis facilities shapefile, and then results facilities, that's for the result fields. And then we put the buffer distance 500 meters, and then we put the string and we select it's all. So let's bring the buffer tool again. Buffer, come back, dissolve. Okay. And we have all. So here, that's the special. All buffers are dissolved together into a single feature, removing any overlaps. So that's how we get here. And then we run the code. All the buffer features are dissolved into a single multiple feature. So now, so far, the tool parameters have been hard-coded. That is, the actual values have been used. Alternatively, we can first assign the value of a parameter to a variable and then use the variable in the code that calls the tool. So now we're going to run some code. So in features, we will have bike routes, shapefile, and clip features, we will have zip shapefile, and then out feature, we will have bike clip shapefile, and XY tolerance will be nothing here, and I'm going to run it. So now this creates a variable for each of the tool parameters, and next we are ready to run the tool. And we're going to type, we will have, the tool is ArcGIS. We have ArcGIS we're going to clip analysis. And in feature, because we already defined, in features, and then clip features, and then out features, and then X and Y tolerance. Perfect. And now, when we hit enter and then the clip tool is run, and the use of variable is not required, but it gives you your code more flexibility. So we have in feature, clip feature, out feature, and XY tolerance. And now we're going to help with tool syntax. Working with geoprocessing tools in Python requires a good understanding of the syntax of the tools. The proper syntax can be reviewed in a number of ways. So now we make sure the help and syntax panel is visible within the ArcGIS window. At the command prompt, we're going to enter the following code. Without pressing enter, we're going to do is we have ArcGIS and buffer analysis and put parentheses. So now we can see here on the right hand side, I'm going to put them side by side. We can also find the syntax and tool explanation in the item description and help files for each of the tool. So now on the ArcMap standard toolbar, we're going to click the search button, and I already have it here ready. And I have my buffer here. So I'm just click. And now from the results, we're going to click the definition of the buffer, which is right here, and starting with create buffer polygons. Then this opens buffers. So to help there. So the help file is here for us, and we're going to scroll down in the description item. And then we're going to look at here the syntax. So syntax right here. So buffer analysis in features, out feature class, buffer, distance or field, line sign, and line and type, dissolve option, dissolve field, and method. So, and we can see that in feature is input point, line or polygon, features to be buffered, feature layer, it will be a feature layer out, and then it didn't talk about anything. It gave us some code now. So Python referenced the input point, line, polygon features to be buffered. And then output feature class, the feature class containing the output buffers, Python reference. It will be the feature class containing the output buffers, feature class. It will be feature class, feature layer, and buffer distance or field. That is the distance around the input feature that will be buffered. Distances can be provided as either a value representing a linear distance or as a field from the input feature that contains the distance to buffer each feature. If linear units are not specified or are entered as unknown, the linear unit of the input feature's spatial reference is used. When specifying a distance in scripting, if the desired linear unit has two words, like decimal degrees, combine the two words into one. For example, 20, you would type 20 and then capitalize decimal and then capitalize D, degrees. Each word, the first letter capitalized. And we're going to scroll further down in the item description window to see code examples under code samples. So the code samples will have it here. Buffer example Python window. The following Python window script demonstrates how to use buffer tool. And we import ArcGIS environment and workspace. We put the C data, ArcGIS buffer analysis. We have roads, and we put the C drive for the buffer relative path and 100 feet and full round list distance. And here we do have a example that buffer pi description find areas of suitable vegetation which exclude areas heavily impacted by major roads. We import system modules and import ArcGIS from ArcGIS import environment. We set environment settings and environment workplace, and then select suitable vegetation patches from all vegetation. And vegetation is we have veg type. Suitable veg, we put the path name and where clause equals habitat1. ArcGIS select data and vegetation suitable veg and where clause. And finally, code automation, auto completion that prompts can help you write the proper syntax. For example, where you start typing the parameters for the buffer tool, the Python window recognizes which parameters you are currently working on. In the case of the dissolve option parameter, the options are all, list, and none. So when we type in, then previously it gave us the option, so which is right here. So, and for none, an individual buffer or each feature is maintained regardless of overlap. This is the default. So, we want them to dissolve. Anyway, we're going to close that window, and now we're going to explore ArcGIS functions and classes. So all the geoprocessing tools in ArcGIS are functions of ArcGIS. There are also a number of ArcGIS functions that are not tools. So the instructions in this video assumes we are completing all the steps in sequence without closing the ArcMap. So when ArcMap is closed, any code entered in the Python window is removed from memory. That's why previously I had to redo everything because I had to paint my wall. As a result, when restarting ArcMap, you may need to re-enter portions of earlier code. So in this case, we do not, because I'm still working on it. And we're going to run the code right now. So I will close this out, and I'm going to delete this because we don't need to use it, but I do have to use ArcGIS dot exists, and then I'm going to put is hospitals. So the result is true. Then from ArcGIS import environment there, and then environment workspace equals to my exercise 5. Oopsies. Shoot. I need to bring it back. Control C and then Control V. There. And then I'm going to run it. So, unlike with ArcMap,